Hello everyone, welcome to the next lecture on the complex analysis. Today I will explain you the 10 plus numerical examples related to the Rouche theorem. Myself Dr. Harish, you can follow and subscribe my YouTube channel where you can find the playlist of the complex analysis. In this playlist you can see the various lectures related to the complex analysis available in this playlist with the help of the easiest way. You can follow and subscribe my YouTube channel. We have stated and proved the Rouche theorem in our last lectures, and in this lecture we will cover the 10 plus numerical examples. If I quickly recall the statement of the Rouche theorem, that means if you have the two complex function f and g which are analytic inside and on the boundary of the contour, such that the value of the g is strictly less than, remember, it is strictly less than of the f of z, then the function fz and f plus gz both have the same number of the zeros. Make sure students, if you prove that the value of the fz is less than of the g of z, then you can say the g and f plus g both have the same number of the zeros. Now the most important thing is, whenever you are the part of the CSIR net examinations or you are the part of the gate examination, how do you remember that? How do you know when you can use the Rouche theorem in a particular problem? So the concept is very simple. Whenever you will see the question is related to the number of the zeros, whenever in the statement they are talking about the number of the zeros, you can always apply the Rouche theorem. Always. Fine. For example, if you look at the first question, they are talking about the zeros. Look at the second question, they are again talking about the number of the zeros. Third is also roots. Roots means the number of the zeros. That means all these questions you can solve with the help of the Rouche theorem. But the most important question arises is, what is the value of the f and g? How you can choose the f and g? In this case, it may be f or it may be the g, but how you can choose f and g in a simple manner? Because your Rouche theorem is dependent on only f and g. So I will tell you the simplest way. First of all, your target is to choose the value of the f and g from the given function. Whatever the functions are given to you, like this is my polynomial, you can choose the functions from f and g from them. Once you can choose the function f and g, check whether your chosen f and g will satisfy this property or not. If this property is satisfied, then only you can apply the Rouche theorem. If this property is not satisfied, then you can never apply the Rouche theorem. And once g upon f, absolute value of the g over f is less than 1, you can calculate, clearly say that means the absolute value of the g is less than of the absolute value of the f. That means f is greater than, that means f and f plus g has the same number of the zeros. Now the big question arises is, how we can choose the value of the f and g. So I will explain you with the help of the numerical example. First of all, determine the number of the zeros. Fine. Firstly, draw this circle. This is the equation of the circle. So how you can draw the circle? You can see this is my equation of the circle with the radius 1, and this is the value inside the circle. Fine. Another thing is, always remember, Rouche theorem is always calculate the number of the zeros. That is fine. Always calculate the number of the zeros, but only within the circle, only within the domain, not on the boundary, only on the domain. Now the first is how you can calculate the f and g. सबसे पहले शॉर्टकट ट्रिक्स बता दे रहा हूं आपको मैं, ओके? उसके बाद आसानी से सॉल्व करते हैं. f is always, remember, f is always the single term. F is either z raised to power 10 or f is minus 6 e raised to power z, or minus 6 z raised to power 7 or 3 z cube or 1. Remember, it's always a single term. F can never be z raised to power 10 plus 1 or z raised to power 10 minus 6 z raised to power 7, or 3z cube minus 6z, because it is a two terms. F can never be more than one terms. क्लियर? इतना समझ में आ गया? आसान तरीका बता रहा हूँ, शॉर्टकट ट्रिक्स CSIR नेट और गेट के लिए. F कैसा होगा? F हमेशा सिंगल टर्म होगी. इधर it is only z raised to power 10, it is only 3 raised to power 3 into z power 3, or 1 only the single term. And whatever the rest of the term, whatever the rest of the term in the given function is my g of z. Meaning, if you consider f is my z raised to power 10, what is the remaining? Remaining is minus 6 z raised to power 7 plus 3 z cube plus 1 is my g of z. Is it okay? Now, how you can calculate the f and g? What is the boundary of the circle? Boundary of the circle is my 1. This is my boundary. Calculate the value, calculate the each calculate the each term, calculate the each term on its boundary. Calculate the each term, that is the absolute value of the each term, absolute value of the each terms on the boundary. So you can see what is the value of this on the circle is 1. 1 raised to power 10 is 1. This is number is my 1. Can you calculate the absolute value of minus 6 z raised to power 7, which is 6? 1 raised to power 7, that is my 6. Second number is my 3. Last number is my 1. Is it okay? Look at that, which one is the maximum value? Look at that, which one is the maximum value? The term 6 is my maximum value. Fine. यहाँ तक समझ में आ गया? जो मैक्सिमम वैल्यू है वो आपका f of z होगा. जो भी मैक्सिमम वैल्यू है वो आपका f of z होगा, प्रोवाइडेड एक कंडीशन और लेंगे आपके साथ. पहले मैक्सिमम वैल्यू लीजिए, वो मैक्सिमम वैल्यू मिल गई. अब आप चेक करना है क्या जो बाकी रह गया उसका सम, बाकी जो टर्म्स रह गई उसका सम इस f से कम होना चाहिए. सो क्लियरली से 1 plus 3 plus 1 is less than 6. Yes, satisfied. So therefore your f of z is my minus 6. ये आपका f हो गया. और जो बाकी क्या बच गया, दैट इज द रिमेनिंग टर्म इज z raised to power 10 plus 3 z raised to power cube plus 1 is the g of z. रिमेंबर स्टूडेंट, मैं रिपीट कर रहा हूँ, मैक्सिमम वैल्यू यू कैन ऑलवेज टेकन द लार्जेस्ट वैल्यू. अगर ये कंडीशन सेटिस्फाइड होती है, रिमेनिंग सम इज लेस देन ऑफ द स्ट्रिक्टली लेस देन, तो ही आपका एफ जेड ये होगा. अगर फॉर एग्जाम्पल इफ दिस नंबर विल बी माई से 4, say this number is my 4, then clearly say 4 plus 1 plus 1 is not less than of the 6. So that means Rouche theorem is not applicable on this function. Is it okay? So now for this particular example your f is minus 6 z raised to power 7 and so on. Now both are my polynomials and every polynomial function is my analyte. Fine. This is step number 1. Now you can calculate g over f, which is equal to, can you substitute the value of the g? Now I can use the inequality. This is minus 6 z raised to power 7, z raised to power 7 plus 3 z raised to power 7 plus 1. Again I can use the inequality, z raised to power 10 plus 3 z raised to power 7 plus 1 divided by 6 z raised to power 7. Now you can substitute the value of the mod of z on the circle. What is the value on the circle? It is 1. So this number is my 1 plus 3 plus 1 divided by 6. So that is 4 over 6 is strictly less than 1. Fine. Or you can see 5 over 6 is strictly less than 3 plus 1 plus 1. 5 over 6 is my less than 1. So once both the properties satisfied, therefore by the Rouche theorem, the function f, because this implies mod of g is less than mod of f. So f and f plus g has the same number of the zeros. So can you find the number of the zeros? So clearly say it is my 7th degree polynomial. So f of z, which is equal to minus 6 z raised to power 7. How many zeros are there? Has the 7 zeros in the circle z less than 1. This implies f plus g. F plus g means the given functions has also 7 zeros inside the circle z is less than 1. Look at the second examples. Again, prove that all the are lies between 1 and 2. So what is a circle? You can see this is a circle 1 and this is the circle 2. Your target is to prove all the zeros are lies between 1 and 2. This is my target. Now firstly, I can check on the C1. Fine. So my target is to check on the C1. So calculate the absolute value on the boundary of the circle. This value is my 1. Absolute value of the minus 5 z cube on the circle C1 is 5. On the 12 is my, so can you find the maximum value? This is my maximum value. Fine, this is my f, and clearly say 1 plus 6 is less than 12. So on the circle C1, what is your fz? Fz is my 12 and the remaining part is my g of z. Fine. देखिए कितना आसान तरीका बताया. If you really like that, kindly put a comment and like my video as well. Now every constant function is analytic, every polynomial is analytic, so we can say both are analytic inside the circle C1. Now you can check about gz over fz. फाइन, इसकी एब्सोल्यूट वैल्यू कितनी आई थी आपकी 1, एब्सोल्यूट वैल्यू इज माय 5, एब्सोल्यूट वैल्यू इज माय 12. सो आई कैन टेल यू आल्सो, पहले बता दे रहा हूँ आंसर कितना आना चाहिए इसका, यही प्रूफ करा था ना हमने. सो 6/12 आएगा आपका आंसर इसका. यू कैन सब्सटीट्यूट द वैल्यू ऑफ द gz. नाउ अगेन you can take as this is my 12, this is z raised to power 7 minus 5 z cube. I can also write this number is z raised to power 7 plus minus 5 z cube divided by 12. Again I can written this number is z raised to power 7 minus 5 is my positive 5 z of cube divided by 12. So that will be 1 plus 5 over, this is my half, half is less than 1. So now both the properties satisfied. Therefore by the Rouche theorems, f and f plus g has the same number of the zeros. But what is the zeros? F of z is 12 has how many zeros are there? There is no zero. There is no zeros in the circle less than 1. This implies the given function has no zeros inside the circle z less than 1. Similarly, on the second part, whenever the value of the z is less than 2, this number will be my 2 raised to power 7. This number will be 8 into 5, 40. This number will be my 12. So can you find the maximum value? This number is my maximum. And clearly say 40 plus 12 is less than of 2 raised to power 7. Is it fine? What is the 2 raised to power 7? Is a 60. 2 raised to power 5 is 32. Fine. 2 raised to power 7 is 128, which is clearly less than 128. So f is my z raised to power 7 and the remaining of thing is my g of z. क्या आप कमेंट करके बता सकते हो whether are you able to understand how you can choose the f and g? Let me know in the comment box and don't forget to subscribe my YouTube channel. Therefore, the value of the gz divided by fz, I can write this number is z raised to power 7 5 minus 5 z cube plus 12. This number is my 5 plus 12 and it is my 8 plus 12, that is 42. Fine. Now you can see which is less than of the 1. So by the Rouche theorem, both the f and the fz has the same number of zeros. But can you find the number of the zeros of the fz? Number of the zeros of the fz is, how many zeros are there? Has the 7 zeros, because the degree is my 7. Therefore the given function also has the 7 zeros. But you can see what is the statement says, as I prove that how many zeros which are less than of the 7, how many zeros are which is less than of the 1, there are the no zeros. How many zeros which are less than of the 2, there are the 7 zeros. What does it implies? Can you find the number of the zeros lies on the yellow color? You can see 7 minus 0. So that means The 7 roots are there, and this equation has total 7 0. All the roots are lies between 1 and 2. Look at the next questions. Show that the equation has one root in the disk and the 4 roots in the disk. सबसे पहले इसकी बात करते हैं. Fine. On the boundary of the circle, can you find this number? It will be 3 raised to power 5 over 2 raised to power 5. The value of this will be 45 over 2. This number will be my 1. So what is the maximum value? Clearly say it's a 22 point. This is my maximum value, and the sum of them will be less than of, because this is a 1.5. 1.5 raised to power 5 is always be less than of the 22. So 15 f z is my f of z, and the remaining is my g of z. You can calculate the g over f, which is less than of z raised to power 5 plus 1 divided by 15 into mod of z. I can substitute the value. It is 1.5 raised to power 5 plus 1 over 45 divided by 2. Now you can calculate this value. This number will be 0.3819, and you can see this is less than 1. Therefore, by the Rouche theorem, both the f and f plus g has the same number of the zeros. Can you find the number of the zeros of the fz? Because the degree of the polynomial is 1, so it has only 1 zeros inside the circle. Z is less than 3 by 2. Therefore, the given function has only one root in the disk, z less than 3 by 2. Look at the second part. Again, this is a 3 by 2. We already computed is a 1. Now I can compute the root which is of the 2. Can you find this value? It is 2 raised to power 5. 2 raised to power 5 is my 32. 15 into 2 is my 30. And this number is my 1. So clearly say this number is my maximum. So f is my z raised to power 5. And also you can see 30 plus 1 is less than 32. So f is my z raised to power 5. G is my remaining things. You can calculate this ratio, and you can easily see this number is my 31 divided by 32, which is less than 1. Again, by using the Rouche theorem, you can see both have the same number of the zeros. But can you find the root of the f of z? Is of degree 5. Therefore, f of z has 5 number of the zeros. This implies the given function has also 5 zeros inside the circle. But my target is to find the roots in between them. That means our target is to find the roots in between them. How many roots are lies less than of the 3 by 2? One root. How many roots are lies less than of the 2? That is a 5 roots. So how many roots are lies in between them? 5 minus 1. 4 roots are lies in between them. Look at the next question. If A is greater than of the E, then use the Rouche theorems, prove that the equations has n number of the roots inside the circle. So I can look at the functions e raised to power z minus a z raised to power n on the circle z. So what is the value of this number is e. What is the absolute value of this number is a, and clearly say a is greater than of the e. So this number is my maximum value, and minus a. So what is your f? F is your minus a z raised to power n, and the g is my remaining part. And both are my analytic function, because this is the polynomial, and exponential function is always analytic functions. Now you can start with the ratio. How you can write that? This is e raised to power z divided by a z raised to power n. E raised to power 1, because on the circle is a 1, e over a, and what is the value of the e over a, which is less than 1. So therefore, by using the Rouche theorem, both the f and the f plus z has the same number of the zeros. So can you find the number of the zeros of the function f? What is the degree of the polynomial? That is the n. So f has n number of the zeros. This implies the given functions has n zeros inside the circle less than 1. Look at the another one. Your target is to find the number of the zeros lies between 1 and 2. That means again what I can do, I can find the number of the zeros which are less than of the 1. I can find the number of the zeros which are less than of the 2, and then I can subtract them. Let's firstly do on the circle 1. What is the value of the first component is 2. The value of the second, always taken the absolute value. This is 6. Third component is 1. Fourth component is also 1. So you can see the largest value is my 6, and clearly say 2 plus 1 is less than 6. So f is my minus 6 z square is the value of the f of z, and the remaining part is my g of z. You can start with a g over f. I can write this number is twice z raised to power 5 plus mod of z plus 1 divided by 6 z square. Fine. I can substitute the value of the mod of, what is the mod of z on the circle is 1. So this is my 2 plus 1 divided by 6. So that number is 4 over 6, that is less than 1. Therefore, by the Rouche theorem, both have the same number of the zeros. Can you find the number of the zeros of the fz, which is a quadratic equations? So it has the 2 number of the zeros. Hence, the given series or the given polynomial is also the 2 zeros less than of the 1 radius. Now I can find the number of the zeros on the circle 2. Can you find the value of on the circle 2? This number will be my 2 into 2 raised to power 5. That will be my 64. Fine. This number will be 4 into 6. 6 into 2 square. 4 into 6 is a 24. Second number is my 2. Last number is my 1. Clearly says 64 is my largest, and the sum of the remaining term is less than of the 64. Therefore, my f of z is 2 into z raised to power 5. And because both are my polynomials, so every polynomial is my analytic functions. You can start with a ratio. I can write this number is 6 into z raised to power 2 plus mod of z plus 1 divided by twice z raised to power 5. I can write this number, this is my 1 plus 1 divided by, sorry, on the circle 2. On the circle 2. So this number is 4 into 6, 24 plus 2 plus 1 divided by 64. So that number is my 27 divided by 64, which is less than 1. Therefore, by using the Rouche theorem, we have the same number of the zeros. So the given function fz has the degree is 5, so which has a 5 number of the zeros. Therefore, the given polynomial has also 5 number of the zeros inside the circle. But our target is to find the number of the zeros inside the ring. So we have seen the number of the zeros which are less than of the 1 is my has 2 zeros. Number of the zeros which is less than of the 2 has 5 zeros. What does it implies? How many zeros which are lies between 1 and 2? So 5 minus 2, that is a 3 number of the zeros are lies between 1 and 2. Okay, look at this another one. Find the number of the zeros inside the region mod of z is less than 2. Can you find the values? On the circle 2, what is the value of this? This is my 16 number. This is again 16. This number is 436. This number is my 2. This number is my 1. Always calculate the absolute value. And what is the largest number is? 36 is my largest number. So can this be the fx? We can see 16 plus 2 plus 1, which is my 32, 30, 35, and which is less than of the maximum value. Yes, f of z is my 9 into z square, and the remaining one is my g of z. Both are my polynomials, so therefore they are my analytic. Once they are analytic, you can start with the ratio. I can calculate this value is z raised to power 4 plus twice z raised to power cube plus mod of z plus 1 divided by 9 into z square. On the circle 2, I can substitute this value. 2 raised to power 4, 16 is again a 16 plus 2 plus 1 and 4, 9 for the 36. So that number is my 35 divided by 36, which is less than 1. Therefore, condition of the Rouche theorem satisfied. Hence, the given function fz and f plus z has the same number of the zeros, but f of z has two zeros which are lies inside the circle of radius 2. Therefore, the given function has also two zeros. Look at the next one. Calculate the number of the zeros on the circle less than of the 2. So can you find that quickly? On the circle 2, this number is my 32, 8 3 are 24, this number is my 4, this number is my 1, and clearly say the maximum value is my 32 and the sum of the remaining number is less than of the 32. That means f of z is my z raised power 5 and remaining one is, so what is the answer, number of the zeros? So number of the zeros will be by 5 as per the f of z. I can start with the ratio and you can see the ratio will be 29 divided by 32. By using the Rouche theorems, f of z has the 5 number of the zeros. Therefore, the given functions or the given polynomial has also 5 number of the zeros less than lies inside the circle of radius 2. Okay, show that the functions z raised power 5 has 1 0 in the first quadrant. Fine. Now you can see z raised power 5, 2, 2z plus 3. So what is the radius of the first quadrant? Lies in the first quadrant, that is it is r, while angle is lies between the first quadrant. But what is the value of the r? What is the r? Is it given to you? No. Fine. So what is the value of the r? For example, if you choose r is 1, then this number will be my 1. This is also 1. This number is my 2. This number is my 3. Maximum value is my 3, but clearly say 1 plus 2 plus is not less than 3. That means the Rouche theorem is not applicable. On the other hand, if I consider r is my 2, then it is my 32. This number is my 8. This number is my 16. This number is my, sorry, r is my 2. So this number is my 4. So clearly say 32 is greater than of the sum of the other. But what is the value of the r? In the first quadrant, r may be 2, r may be 1, r may be 0.3, r may be 100. So it is not given to you. Once it is not given to you and clearly say for the particular value of the r, this condition not satisfied, that means you are unable to find the value of the f and the g. Once you are unable to find the value of the f and g, how you can find the number of the zeros? I can apply the argument principle. I think all of you remember my last lectures. If you remember my last lecture on the argument principle, you can see examples of the argument principle. What is the argument principle is? N minus p 1 over 2 pi iota f dash over f, which is also same as of argument of the f of z. So I can use this principle. In the first quadrant, the equation of the circle is, or the complex form is r e raised power iota theta, where r is any larger number. Fine. Now, how you can find the zeros of the given functions? Clearly say the function is my analytic. I can use the argument principles. Fine. Because the function is my analytic, so the pole is my zeros. Therefore, number of the zeros is my 1 over 2 pi argument over the curve of the fz. What is the c? C is my curve. In this particular example, the curve is my OA, that is curve is my OA, and then AB, and then BO. So I can replace this change in the curve, that is a OA plus AB plus BO. So my target is to find these three numbers. Fine. So let's start with this one. On the curve OA, the value of the y is my 0, the value of the z is my x. Fine. This is the value of the z. On the curve AB, the value of the z is my r e raised power. On the curve BO, x is my 0. Therefore, z is equal to iota y. So I can substitute the value of the z in the first functions. What is the value of the fz? It is x cube plus x raised to power 5 plus x square and so on. How you can find the argument of the functions? So we all know for the complex functions, what is the argument? Argument is tan inverse imaginary part of the z divided by real part of the z. So can you find the imaginary part? That number is my tan inverse. What is the imaginary part? 0. Real part is a complete number. So argument will be 0 because tan inverse 0 divided by x raised to power 5 and so on. The answer is my 0. So once you can 0, therefore argument over the curve OA of fz, which is 0 on the first quadrant from the 0 to pi by 2, that is again 0. On the curve AB, I can substitute the value of the z in the given functions. I can calculate this result. Again, I can take an r raised to power 5 as a common. You will get this expression. Now when r is very large, so clearly say when r approaches to the infinity, because the first quadrant is my, what is the radius in the first quadrant? Infinity. So this number will be 0. Second term is also 0. Third term is also 0. So that means this value will goes to the infinity. Fine. Or this term will dominate the nature. And once f of z is my, so can you find the argument of the fz? So clearly say the argument is my 5 theta. Fine. Once the argument is 5 theta, can you find the argument of the AB of the f theta? So that will be 5 theta from 0 to pi over 2. So the answer is 5 pi over 2. Similarly, for the third curve, on the curve BO, equation is my x is 0, z is equal to iota y. So I can substitute the value of the z. It is iota raised to power 5, y raised to power 5, iota cube, y cube plus 2 iota y plus 3. What is the iota raised to power 5 is? Iota into y raised to power 5 minus iota y cube plus 2 iota y plus 3. Fine. So therefore what is the argument of the fz? That is a tan inverse imaginary part divided by the real component. Real is my 3, imaginary part is 2y minus y cube plus y 5. Therefore once you know the argument, therefore BO, make sure the direction should be fixed. It's a BO, that will be tan inverse of 2y minus y cube plus y5 divided by 3 over the angle. So what is the value of the y from the B to O? So B will be my pi by 2 to 0, or you can say from the 0 infinity to 0. The value of the y is my infinity on the first quadrant. What is the value of the y? What is the value of the y at the point B? Is my infinity. Value of the y at the point is 0. So tan inverse 0 is 0. Tan inverse infinity is my pi by 2. So the answer is minus pi over 2. I can substitute all these values in the given functions. You can see the number of the zeros are 0 plus 5 pi over 2 minus pi over 2. So you can see the answer is 5 minus 4 1 4 4 over 2 is 2. So number of the zeros is my 1, and that's the same statement they are asking. So the number of the zeros are only my 1. Fine. So you can see that it's a very simple way you can find the Rouche theorem application in a simple manner. I hope you can like and comment on the video as well. We will see the next lecture on the residue of the function very soon. Till then, you can share this video with your friends and don't forget to like this video as well. I thank you for the watching and don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.